meeting is being recorded.
Okay, thanks, Jeff. So I'm going to go ahead today. I think everybody can see my screen, and focus a little bit of time about talking about Delaware system operations. First, just a quick overview of the New York City water supply. So it is a surface water system, 19 reservoirs, 3 controlled lakes. There's 570 billion gallons total storage in the reservoirs. It's a big, robust system broken up into 3 different subsystems: the Croton system, the Catskill system, and the Delaware system. And it's big and robust because it needs to be. We supply water to half the population of New York State, 9.8 million people, about 8.8 million in the city, and about another million people north of the city line in Westchester, Dutchess, and Orange counties. We deliver approximately 1.1 billion gallons of water each day. About 1 billion of that goes into the city, and about 100 million gallons serves the upstate communities. The watershed in and of itself is about 2,000 square miles, again, in 8 upstate counties, and a little sliver in the state of Connecticut. That's really just the top of the mountains where the water runs down into New York. It is the largest municipal water supply in the country, and about 90% of it is actually unfiltered. So water supply operations, when we're operating this system, there's a bunch of things that we take into consideration. Our essential tasks when we're operating the system, first and foremost, is to meet the supply needs of New York City and the upstate communities. We also have to meet all of our reservoir release and diversion requirements as we're doing this. And we need to be able to maintain the system to ensure a dependable supply. So that's regular maintenance, state of good repair, things break, it's a mechanical system. So that's the maintenance to keep the aqueducts, the reservoirs, all the valves going to make sure that we can meet demand and our releases requirements. So our objectives when we are looking at where to take the water from, we want to be able to divert the best water quality available. 90% of the system is unfiltered, as I said, so water quality plays a huge role in where we take the water from. It's not just quantity, it is quality as well. We also strive to maintain a balanced system. So we look at what the probability of refill of all these systems are, looking at, Catskill separately, Delaware separately, Croton separately, and then the entire system as a whole. The goal is to draw down the system equally so that we are not depending on one supply more than another. But all the reservoirs are different shapes and sizes, so they draw down differently, they refill differently, their individual watersheds are different sizes. So it's a lot to look at in order to be able to maintain the system in balance. So while you may see larger diversions coming from one system, you also have to keep in mind that certain systems are larger than others, and those reservoirs refill faster than other ones. So we also aim to provide downstream habitat and flood mitigation benefits without impacting the water supply. Now that's very different than how we used to operate the system. So I would say since the development of FFMP, New York City has really changed the way that we operate the system. We used to just fill and spill the reservoirs and paid relatively little to no attention, to downstream needs or the stakeholder wants, needs, and desires. But a lot of that has changed. That's been, since a huge leadership change here at DEP. And now the goal is, as we are operating the systems, one of the objectives is to try to meet as many needs as we possibly can, but making sure that while we do that, we don't impact the water supply. I also want to make sure that people realize that there is a lot of regulation into these reservoirs. We just don't willy-nilly operate them, to however New York City feels we want to. There's a lot that goes into how both the diversions and releases are all made. So as Amy alluded, we had the 1954 Supreme Court decree, the 1982 Good Faith Agreement. New York State also has its own regulations as to how the different parts of the system are operated. We have FFMP, we have Speedies permits, we have an interim operating protocol on the Shokan side, and then a Schoharie snowpack void program that also gets taken into consideration as we are operating, these reservoirs. So we are regulated. just to make sure that people understand, there are lots of rules that New York City has to follow when we are operating the system. I also want to highlight that not all New York City systems are created equal. So looking at the pictures on the bottom of the screen, the first one down on the bottom left is the Croton system. Croton is a very, it's Westchester County. It's very urban compared, to the Catskills and the Delaware. So we tend to have, algae problems. We have some taste and odor issues that occur down there. On the Ashokan side, you can see the picture here. This is a picture after a storm where there's turbidity issues. You can see the water spilling over from the West Basin to the East Basin. Ashokan was designed specifically that way to help settle out turbidity in the East Basin so that we could maintain good quality water. And then the photo on the right is Rondout Reservoir, on the last stop for the Delaware system. Canonsville, Papacton, and Neversink reservoirs all feed Rondout, and then Rondout Reservoir is the start of the Delaware Aqueduct. So when we are making operational decisions, we're looking at several things. Water quality, there is some of the issues that I mentioned before. We take about more than 100,000 samples a year coming out of all the reservoirs and some of the stream sites, and we conduct about 580,000 water quality analyses a year, looking at several different parameters that help us decide, where we should be taking the water from based on quality as well as other things. Demand in the city and in the upstate communities. Modeling helps drive our decision making, which I will get into a little bit more. National Weather Service forecasting, maintenance, again, the system is mechanical, so we need to be able to take parts of the system out of service every now and then to be able to repair it. I know everybody is aware of the Delaware Aqueduct shutdown coming up next year. That's part of, taking into consideration how we operate the system, as well as current hydrologic conditions. So New York City has what's called the Operations Support Tool. So this is our big modeling system that models the system. It has a probabilistic foundation for water supply reliability. There are more than 1,600 inputs into the system. So that's, real-time data sources, USGS stream flow, National Weather Service forecasting, our own internal data here, water quality data, a lot of different data points. So what it allows us to do is develop a more accurate assessment of likely future inflows into the reservoir. It helps us better predict what our release requirements are going to look like, our storage levels, the drought warning triggers, all that comes with operating the system. It works to better define the system capacity to meet our objectives. And a few years ago, the National Academies of Science, Engineering, and Medicine did a review of the operations support tool, and they actually called it the most complex and advanced tool of its kind in the world. So I also want to hit home, it's named appropriately. It is the operations support tool, not the operations decision-making tool. This is just one tool that New York City uses in its daily operations. So quickly, I want to hit on the OST FFMP summary page. It's a 4-page long document. I'm really just going to focus on the first page. These documents come out typically monthly, about mid-month. It goes out to the decree parties. The Office of the Delaware River Master posts it on their website. New York City DEP posts it. We post it on our website. And what this does is it tells us what FFMP table we're in. So Amy talked a little bit about the tables, and I want to just hit a little bit on this concept of forecast available water and how we use OST to determine what table we're releasing at. I also want to say that this page also gets issued whenever we have a table change. So typically we don't change tables very often, but during this last dry period, we changed tables for a little bit, probably on like a 2-week period. The last one that went out was this one that's actually on the slide here. We're currently in table 4F. We're expecting some rain on Thursday, so we're hoping that that's enough to increase storage in the reservoirs so that we can go up to table 4G. So this is the very top of the FFMP summary page. So the general release mass balance here. So we're looking at the combined storage of Papacton, Cannonsville, and Neversink reservoirs. So you can see this 167,660 million gallon number. So this number is taken based on the data that we have on the observed decision day, which in this case was September 29th, 2020. So the Papacton, Cannonsville, and Neversink inflow forecast accumulation to June 1st. So this is the forecasted inflow based on recent and forecasted hydrology. So this is what we expect the reservoirs to accumulate between, on this case, September 29th, 2022 to June 1st of 2023, because that's our water year. So June 1st is the beginning of our water year. So June 1st to May 31st, that's how we operate. So we are looking at, how much water do we think, based on the forecast, is going to come into the system by June 1st. We also take a look at what we expect to divert. So what New York City expects to use to meet demand between now and June 1st. So then that's that number here, this 147,312. That's how much water we expect to use out of the Delaware system between now and June 1st. The last thing we do is we subtract out the June 1st storage target. And that's what the number is in PCNN when the storage is at 100%, because our goal is to get the system full at the beginning of the water year before we go into summer drawdown. We want the reservoirs to be full. So what if you take the current storage, you add the inflow, you subtract out what we expect to divert, and if you subtract out the storage target, that gives us what we call the available release quantity accumulated to June 1st. So that number came out to be 96,118 million gallons. So we're going to take that number and we're going to use it to calculate, the available release quantity evenly distributed to June 1st. So we take that number from up above and we divide it by how many days are left in our water year, so to June 1st. So in this case, when we did this on September 29th, there were 245 days left. So that gave us a release target of 392 million gallons, or 607 CFS. So then we go and we look at the tables. So we have that 600 CFS number. We know what current storage level we're in. So right now we continue to be in storage level L2 because it's still dry. The reservoirs are not that full still. So it gives us a target. So we look at what this last column is, this PCNN L2, and we see where we fall below. So as you can see, we were pretty close to hitting that 4G number at 615 CFS, but we always go below what this target is. So in that case, that gave us a target of 550 CFS and kept us in table 4F. So we actually went up. We were in table 4E before we made this change on September 29th, and we went up a table to table 4F. And again, I'm predicting that once we do this after the rain on Thursday, we'll be coming up probably early next week into table 4G. So I know that's a lot to take in. And we do this calculation multiple times a week. It does not change that often, which is why this document typically only gets issued once a month. Again, it is posted on the ODRM website. It is posted on the New York City DEP website. I encourage you to go in and take a look. I only went through the first page. There are 3 more pages of information in there. There's some storage graphs in there so that you could take a look and just get an understanding of, you know, what the numbers are, where they're coming from, and what they mean. And so what does the table mean, and how do we get there? I also want to give a plug to Garth Pettinger. Garth has proposed a different way of calculating what table we're in other than the New York City method. So we are currently evaluating you know, what that looks like. When we did our initial calculations, it looks like overall releases for the year stay the same out of the New York City reservoirs, but there is a bit of a seasonal shift. So more water would be released in the summertime and less water in the late fall, early winter time. So we need to take a look to see what that does to habitat. And we will do that with New York State DEC fisheries and with Pennsylvania Fish and Boat to make sure that any changes we make meets the goals of those resource agencies. But that is something that is currently underway. So I also wanted to take a few minutes just to show you some of the other tools that New York City uses. We don't just rely on modeling. When we are making our decisions, there are several things that we take a look at when we're doing this. So NOAA issues a tropical forecast. So this is the one that was, it didn't copy and paste very nicely, but this is the one from Hurricane Ian. They issue these weekly, and we use them to take a look at potential incoming storms to our area. Are we going to get hit with these big storms? Are they going to go out to sea? Are they going to come up the coast, or are they going to go inland into the Gulf? NOAA does a very good job of tracking these storms, and this is one of the tools that we look at. Another one that NOAA produces are short-term type forecasts. So they range anywhere from 6 to 10 days. They come out in 8 to 14, 3 to 4 weeks, monthly, and then seasonally. By seasonally, that's usually like a 3-month window in which they come out. The shorter term forecasts get updated weekly, and then the monthly and seasonally ones usually get updated toward the end of the month. So they do these for both temperature and precipitation. So these were the ones that were issued at the beginning of September. So taking a look at these, the short-term forecast shows temperature above normal, while the precipitation is showing a little bit below normal. But parts of the basin are starting to hit this near normal look, like normal type conditions and normal precipitation. However, when you continue to look at this, it continues to show us above normal temperatures and below normal precipitation for the longer term. We also look at the US drought monitors. These have not been updated yet. I did not get the ones for September, so there are more updated ones. The drought is starting to lift a little bit in the Delaware River Basin, but we are not totally out of the woods just yet. So we look at these both short term and seasonally. So we are also looking at the regional climate centers and what they're predicting. So it shows a departure from normal precipitation for a 1 month outlook. So as you could see, parts of the basin are still in that drought area, while some of the upper basin is looking like it could start to recover here. And then the other graph just shows a longer term look. It shows that 3-month period of what we've seen, what the trend has been over the last 3 months. So we also look at the USGS stream gauges. So they do both this current graph, which you can go on and look at the USGS website. It shows the different stream gauges in the basin and what they're currently hitting, whether they're at normal, above normal, below normal. Plus, they also give a time series plot of real-time stream flow compared to historical stream flow on that particular day of the year. So looking at the last 45 days, this is what it looks like, on average. So again, these are more tools that we are using for operations. So not just the tools, we are talking to a lot of people as we make our decisions. Our decisions are not just made in a vacuum here. So we are talking to ODRM and DRBC as part of the daily design process. Also with the National Weather Service coordinating with the Binghamton, Albany, and New York City offices. They have a meteorologist in charge that we have very good relationships. Plus they have a service hydrologist. So if we see something funky, like if we see a storm coming in and there isn't great predictability between the different forecasting models that we look at, we can ask that service hydrologist to do a forecast specifically for the Delaware River Basin or the New York City system as a whole, so that we could take that forecast and use it with our modeling to get a better sense of how the system is going to operate. We also coordinate with the climate prediction centers on short range products and the seasonal outlooks that I showed earlier. Also the National Drought Mitigation Centers for the drought monitor and the seasonal drought outlook, and the Mid-Atlantic and Northeast River Forecasting Centers. So the Delaware River Basin is in the Mid-Atlantic. However, the Hudson Basin is in the Northeast River Forecasting Centers. So there's coordination going on with both of them. And I'd just like to point out that during this last dry period, the Mid-Atlantic Forecasting Center actually created a drought advisory committee meeting that met once a month, and we were on those calls. But no matter what the hydrologic conditions are, whether it's dry, whether it's wet, whether we're in normal conditions, the same tools and same coordinations are happening. So I know there's been a lot of concern about flooding, like when we shut down the Delaware Aqueduct, but these are the things that we're looking at. These are the people that we are talking to. There's also, a very robust team here at New York City DEP that is working on reservoir operations. It's not just one person sitting in an office or in a box. So just to close this out, New York City operates under a series of regulatory frameworks. Again, we are regulated in what we do, both on the diversion and the releases. There's a lot of communication and coordination at the agencies at a variety of different levels. We use a multitude of tools, and they are validated tools, to make decisions. And, New York City DEP and ODRM websites provide a lot of information about current operations. DRBC's website has that as well, as Amy showed. And I think this is the point where Amy and I will go ahead and start taking questions. So I'm actually going to stop sharing my screen so that we can do that.